Again, this isn't that bad, but what if you don't know which player's name you want to print? So we want to give the winning player, and congratulations, winning player name is the winner. Alright, so this is a better example. Or what if we aren't making a 2-player game, but something more complicated, such as an online shopping site with a large inventory? In that case, using objects to keep track of an item's name, price description, and other things is the only way to go. Unfortunately, in that type of situations, manually typing out the contents of our objects is not feasible either. We need a cleaner way to create our objects, which brings us to object constructors. Right. When you have a specific type of object that you need to duplicate, like our player or inventory items, a better way to create them is using an object constructor, which is a function that looks like this. So function player and name and marker. So we provide the name and the marker, and then we set them with this dot name equals name and this dot marker equals marker. Okay, and which you use by calling the function with the keyword new. So const player new player. So this is how you fill it. You make a const player, and then when you want, for example, the name of the player, you type in the variable name, this variable player dot name. Because I was just wondering, if that's how you make the player, how do you call like the player name, for example, or the marker? But here you can use the variable still. Okay, sure. Just like with objects created using the object literal method, you can add functions to the object. So we can have a function this.sayName equals function that console walks this name. Sure. Steve, also Steve, same name. Alright. Exercise. Nice, we have an exercise. Write constructor for making book objects. We'll revisit this in the next project. Your book object should have the book's title, author, and the number of pages, and whether or not you have read the book. Put a function into the constructor that can report the book info like so. Alright, so it says name of the book by the author, number of pages, and the status if it's read or not. Note, it is almost always best to return things rather than putting console walk directly into the function. In this case, return the info string and walk it in the function after the function has been called. So console walk the hobby.info. Before we go much further, there's something. Alright, so this is not part of the exercise, so I guess let's create that. That should be fun. Let me see if I have to make a new repository, or I already have something like that. We have JS Prac, JS DOM, we have JavaScript exercises. We can maybe use the JavaScript exercise. Alright, so let me open up the terminal and we'll cd into repos and cd into JavaScript exercises, make dir I misspelled the directory name. RM. Was that how you cannot remove? how did you remove a folder? How to remove a directory? Remove the alright, ls, and we shouldn't have it anymore. Alright, so let me actually write correctly. Object constructor. Alright, cd into that object, oops, sorry, book object constructor will touch HTML and will touch script.js and open that. Oh, sorry, I didn't show the terminal commands. Sorry about that. Anyways, I just created a simple folder with index.html and script.js. I'm quickly going to link it, although I don't know if I need the index.html. Can I just use the JavaScript standalone? I'm not sure. Anyways, let's just link it. Script src script.js, and we'll go live with it. Then we'll alert low. Alright, so it works. Perfect. Now let's copy the constraints from here. Or actually, let's do that. We'll do const book and was that how you define it? No, it's a function. Sorry. So we'll make a function book that will take in the book name, the author, pages num, and is red, and that will do this dot book name equals book name, this dot author equals author, this dot page num equals page num, and this dot is red equals is red. So we also need a this dot info, which is that how you define it? No, we actually kind of do it like that. I just forgot to add function in here. So then we can say to it is almost always best to return things rather than putting console directly into the function. In this case, return the info string and log it after the function has been called. Return the info string and log it after the function has been called. So you mean put a return in here, a return, and we'll do what is it? Is that not how you... Wait. Book name. Am I doing something wrong? Ah, yeah. The back quotes. I forgot. Alright, so by, and we do the author. Then after that, comma and the number of pages. So what is that? Pages num, and now I can just return, well, when creating the book I can type out not read yet and just put it in here, like just give that is read, and that will return it. I want it to be a true or false, but then I'll have to implement some extra logic into that to determine is read. Anyways, I'll leave it at that for now, and we'll see later. Now let's save that. I'll open up the console in here, and this is the sources. I need the console. So can we then do const book1 and then equal new book that will have do we have to provide strings Minecraft book, then we'll provide the author, notch, pages num, we'll do 327, and is read not yet. Alright, so we do that, and what is up with that? Why is it underlined? Expected. New player, function player. I also think when it's functions you can use capital letters, but it seems like it's not exactly that. New book. Why is this underline? A comma expected, where? Oh, maybe the new is not with a capital letter. Yep, that was it. Alright, so then we can console.log. Let me go to here, console. I also have another VS Code, I don't need that. I believe in you, bro. Thank you so much, my guy. I remember you from past streams. How is your day going? And we're returning book.info. We'll console log in it. So let's see now. It says this.info is not a function. Alright. So how did they make the function? Wait. I don't need the brackets in here. Also not in here probably. Book is not defined. 13, so book 1, we need to call it on this one. Alright, and I think I need the brackets here actually, so Minecraft book by Notch 3 to 7 not yet. So it's like the example, I console the hobbit.info and then I get the name of the book by whoever, the number of pages, and not read yet. So I think we've made it correctly. Let me where is the terminal? Sorry, so this one should be it. No, this is the one. I'm just going to quickly add, wait, let me check git status, and it says branch is up to date. Wait, cd. Alright, so then we can git add o and git commit. Wrote my first constructor in JavaScript, and that we can push git push. So come back, hey man, yeah, thank you for joining again, my guy. Did you have a good night's sleep? Just woke up like an hour ago. Yeah, I just finished work and I'm back to streaming. I just couldn't wait to dive into JavaScript once again. We just made a constructor. So this is the constructor, this is how you define the author, the book name, so on and so forth, and after that you can console log it, and you can change the book's name, so on and so forth, define multiple books. Okay, so the prototype. Before we go much further, there is something important you need to understand about JavaScript objects. All objects in JavaScript have a prototype. The prototype is another object that the original object inherits from, which is to say the original object has access to all of its prototype's methods and properties. Let's break it down. So all objects in JavaScript have a prototype, okay? Pretty straightforward sense here. Sentence, every object in JavaScript has a prototype. So for example, player1 and player2 objects from before, created with the player name and marker. Object constructor also have a prototype. Now what does having a prototype mean? What even is a prototype of an object? The prototype is another object. I wonder if the prototype has a prototype. This sentence also seems pretty straightforward. The prototype is just another object. Again, the player1 and player2 objects. Again, like the player1 and player2 objects, the prototype object can have properties and functions just as these player objects, and properties like name, marker, and functions like say name attached to them. Can't wait to get into JS as well. I'm 45% in foundations. Wow, good job. So you're pretty close actually. I think it wasn't that much HTML or CSS, or I don't know, I've passed through it pretty quickly because I already knew CSS and HTML, but yeah, JavaScript was more exciting there, and you get to build some pretty cool stuff. The last project, the calculator, was a bit challenging. It was very interesting how you make everything, the DOM manipulations, all that. So you have pretty interesting stuff ahead of you. Alright. That the original object inherits from and has access to all the prototype's methods and properties. So here the original object refers to an object like player1 or player2. These objects are set to inherit, or in other words, these objects have access to the prototype's properties or functions if they have been defined. For example, if there was a say hello function defined on the prototype, player1 can access the function just as if it was its own functions, player1.sayHello, but it's just not player1 who can call the sayHello function. Even player2 can call it, since it's defined on the prototype. Read on to know the details of how it works and how you could do this yourself. Accessing an object's prototype. Conceptually, you now might feel like you know, or at least have an idea of what a prototype of an object is, but how do you know or actually see what the prototype of an object is? Let's find out. You can try running the following code in the developer console of your browser. Make sure you've created the player1 and player2 objects from before. So we're quickly going to copy that, pasting here. The good old object-oriented programming sucks to learn, but very important as well. Yes, indeed, I have learned it before in Java, but I've forgotten most of it, so I feel like a complete beginner. I know functional programming is another way of doing it, and people say it's better actually, but yeah, I don't know. Also, this actually they're trying to access the prototype, and I think I have to copy those ones actually first before that. Okay, so it's Steve, also Steve, but object get prototype. Alright, so I'm putting those in the, wait, do I have to put them in the console? So it is object get prototype of player1 triple equals player.prototype. It returns true. Okay, I'm still not sure what it means. Is it checking if there is a prototype of player1 and player2? Now if I say like player3, it should return none, right? Yep, player3 is not defined. Alright, so let's see what that means. Now to understand this code, let's use the 3 points from earlier. All objects in JavaScript have a prototype. You can check the object's prototype by using object get prototype of function on the object, like object get prototype of player1. The return value result of this function returns to the prototype property of the object constructor. In example, player name and marker. Object get prototype of player1 triple equals player prototype. The prototype is another object. The value of the object's constructor.prototype property, in example player.prototype, contains the prototype object one shot every time I say prototype. See how long you last. The reference of this value of player.prototype is stored in every player object every time a player object is created. Hence you get a true value returned when you check in the object's prototype. So I think that's exactly it. It checks if we have if player1 has a prototype. That the original object inherits from and has access to all of its prototypes, methods and properties. As said in the earlier point, every player object has a value which refers to player.prototype, so object.getPrototype of player1 triple equals object.getPrototype of player2 returns true. So any properties or methods defined on player.prototype will be available to the created player objects. One shot every time you read equals. Indeed. I didn't register that, but there are a lot of equals as well. The last sub item needs a little more explanation. What does defining on the prototype mean? Consider the following code. So you have player.prototype.sayHello function, and it will console log hello, I'm a player. So player1 can say hello and player2 can say hello. Now I think the fun thing will be if you define the player's name in that console log. So make it hello, I am player 1 name. So each player, when it says hello, it is not defined on the player 1 or player 2 object, but every player can say hello with their name. This is kind of the object-oriented way of doing it. At least that's what I remember. Here we define the say hello function on the player.prototype object. It then became available for player 1 and player 2 objects to use. Similarly, you can attach other properties or functions you want to use on all player objects by defining them on the object's prototype. Let me copy this because I'm curious if we can actually do that. Alright, so after we defined, we can remove this say name and say hello, I am can you do instead back quotes, hello, I'm, undo this dot name. Will that work? Hello, I'm Steve. Hello, I'm also Steve. Yep, so this works indeed. That's very cool. And we define it on the prototype. Nice. Made it to the evening session. Nice. Yep, Supremo Reward. Welcome to the chat. Thank you so much. How's your day? Alright, so here we define the say hello function. Did I already read that? I think I did, but didn't become available. Similarly, you can, yeah, I read through that. Object.get prototype of versus proto versus prototype. Yeah, so I indeed never understood what this is, for example, but we're about to understand, which is pretty exciting. So unlike what we have done so far using object.get prototype of to access object's prototype, the same thing can be done using the proto property of an object. However, this is a non-standard way of doing so and deprecated. System restart required. Okay, it has to wait. Hence, it is not recommended to access an object's prototype by using this property. However, the same code can thus be rewritten to become. So we just replace get prototype of function with proto. Is that what we do? Player prototype. It was, yeah, exactly. But we do object and here we call it directly on the player. So this is shorter, but they say it's deprecated. So they show the way that is not good. That's nice. Yeah, indeed. So at least you know what to use and what not to. In some places like legacy code, you might also come across prototype, which is just another way of talking about the proto property of an object, like player1.prototype. This explanation about the prototype might have been a lot, so remember to take in a breather before moving on. Prototypal inheritance. Now you may also have a question. What you use is an object's prototype. What is the purpose of defining properties and functions on the prototype? We can narrow it down to two reasons. We can define properties and functions common along all objects of the property of the prototype to save memory. Defining every property and function takes up a lot of memory, especially if you have a lot of common properties and functions and a lot of created objects. Defining them on a centralized shared object which the objects have access to, thus saves memory. So this is interesting. I never thought of that, and I still don't fully get it, so I'll need an example or two, but that's interesting. I'm very passionate about saving memory and making things run faster and smoother. The second reason is the name of this section, Prototypal Inheritance, which we referred to in passing earlier in the introduction to the prototype. In recap, we can say that the player 1 and player 2 objects inherit from the player prototype object, which allows them to access functions like say hello. Let's now try to do the following. Do I work this in the console? Get prototype of player prototype. Right, so I think I have to work this in the console. So we get true object get prototype of player 1 prototype triple equals object prototype, and output may slightly differ based on the browser. Player 1 value of, let's do that. We get the object, we get name Steve, marker X, say name, we get the function. Okay. Was this dot value a function, and where did it come from? This is a function of the prototype object. Where did it come from? If we did not define it, it comes as a result of Object.getPrototype of player.prototype having the value of object prototype. This means that player.prototype is inheriting from object prototype. This value of function is defined on the object prototype, just like say hello is defined on player.prototype. Or it is defined on object.prototype. So every object has this value of function. How do we know that this value of function is defined on the object prototype? We make use of another function called hasOwnProperty. Yeah, I know. Going this just by hearing prototype every sentence. I know, my guy. I'm the same. Hello, Alan, you're doing foundations too nice. I just complete my landing page project. Yeah, nice. Alright, so we can call player 1 hasOwnProperty value of, so this will check if the player 1 object has this property value of, and if that's false, we can then check on the object prototype. Yep, true. So we can indeed see hasOwnProperties on the object prototype. I am working on making the Discord, guys, and it should be made in a couple of days, and then there we can share what we've done on the Odin projects and personal tasks. We can also make a community where you can find work, hire people, and so on and so forth. It will be good, I promise. I just need a few more days. Essentially, this is how JavaScript makes use of the prototype by having the objects contain a value to point to prototypes and inheriting from those prototypes and thus forming a chain. This kind of inheritance using prototypes is hence named as prototypical inheritance. JavaScript figures out which properties exist or do not exist on the object and starts traversing the chain to find the property or function, like so. Is the value of function part of the player 1 object? No, it's not. Remember, only the name and marker and say name properties are part of the player object. Is the function part of player 1's prototype, the Object.getPrototype of player 1 value? In example, player.prototype. No, only the say hello function is part of it. Well then, is it part of Object.getPrototype of player.prototype triple equals Object.prototype? Yes, value of is defined on Object.prototype. This is very interesting. That's all good. I always want to be surrounded by people with the same objective as me, but over here is kind of hard. I'm the only software dev from all of my friends. Yeah, I get you completely. Well, at least software development is something you do on the computer, so I guess most of the friends you meet are online along the way. But yeah, we'll definitely make it happen. Right, so where are we? However, this chain does not go on forever, and if you have already tried logging the value of object.getPrototype of object.prototype, you would find that it is null, which indicates the end of the chain. And it is at the end of this chain that the specific property or function is not found, undefined is returned. So we did object.prototype has on property. So we've searched if the object prototype has on property. That's kind of stupid. We're asking it if it has that property by asking with that property. Value of, can we do value of? Yeah, it's true. I just didn't see when I did that. Alright. Every prototype object inherits from object.prototype by default. An object's get prototype of value can only be one unique prototype object. Yeah, share the link definitely. Recommended method for prototypical inheritance. So now, how do you utilize the prototypical inheritance? What do you need to do to use it? Just as we use object.getPrototype of to get or view the prototype of an object, we can use object.setPrototype of, so getters and setters, to set or mutate it. Let's see how it works by adding a person object constructor to the player example, making a player inherit from person. So this is I'm just going to copy that and we'll read through it. Oh, wait. I don't know if I'll just comment everything out. Alright. Do we have any errors? No. And let's read through it quickly. Maybe make it a little bit bigger for you guys. Alright, so it says person with name. So this is the constructor for the person, and it just sets the name we provided. Now we added the prototype by creating a sayName function that will console log hello, I'm this.name, exactly as we did earlier. Function player name and marker, so this will create a player, and then we'll make a prototype function on the player get marker that will say my marker is this.marker. Alright, and this is all inside of the, no, this is not inside of the person function. These are all separate. Okay, after that we get object.getPrototype of player prototype, so it returns object.prototype. Now make player objects inherit from person. How do you do that? Object set prototype of player.prototype person.prototype. Object get prototype of, so again the same thing, but now it will return person prototype. So by default they're saying when you make an object, it will its default prototype will be the object prototype, and we can set it with the set prototype of. We name the object we want to set the prototype of, and get the prototype we want it to be set to, if that makes sense. And then when we get it, when we ask for the player.prototype, it now returns us to person.prototype. So person is now the object that the player inherits from. But I believe person also inherits from object.prototype. So if we say let me grab that and we'll put it in the console. Object get prototype of player prototype, same name. It doesn't. Prototype is object. Player prototype. That's strange because maybe we didn't set it and that's why. Alright, let me do that. This is not for the console. This is I mean not for VS Code. This is for the console. And now if we do again the get, no, we can get that the prototype is object. So this is a little strange. Object get prototype of player prototype. I'm not exactly sure what happens here, to be quite honest. But as you can see, we're able to use functions that we haven't defined in the player object constructor. Like we defined the marker in its prototype, but the same name is defined on the person prototype. And that means if we remove this line and we save it, say name is not a function, so it's not able to access the say name from the person prototype. So indeed, when we set prototype of player to .prototype to person.prototype, it will be able to inherit its functions and values as well. So I guess it works out. I just don't know how to exactly console log it, but that's fine. We saw that it works, and I'm sure they will explain it right now. But they say from the code we can see that we've defined a person from whom a player inherits properties and functions, and that the created player objects are able to access both say name and the get marker functions, in spite of them being defined on two separate prototype objects. This is enabled by the use of object set prototype of function. It takes two arguments. The first is the one which inherits, and the second one is the one which you want your first argument to inherit from. This ensures that the created player objects are able to access the say name and get marker functions through their prototype chain. Pretty cool. Note, though it seems to be an easy way to set up prototypical inheritance using object.setPrototypeOf, the prototype chain has to be set up using this function before creating any objects. Using setPrototypeOf after objects have already been created can result in performance issues. A warning, this doesn't work. It would have been great if that worked, because to set player.prototype to directly refer to person.prototype. In example, not a copy, which could cause problems if you want to edit something in the future. Consider one more example. Alright, so let's copy this one and see what it says. Oops, sorry. We can comment this again and let's see. Paste this out. What does it say in the browser? It says ha ha ha. Alright, we're getting trolled. But again, a person constructor with this .name person prototype.sayName, we make a function that says hello, I am this.name. Function for player constructor with name and marker. This is typical until now. And they say don't do this, object dot set prototype of player prototype, person prototype. So this is commented out and they say don't do this. Function, they say player prototype equals person dot prototype. So function enemy name, this dot name, this dot marker, not again. Enemy prototype, person prototype. So instead of using object.set prototype of, we're using dot prototype equals dot prototype in both of these cases. And instead of getting, for example, what we would have gotten here, set prototype of enemy.prototype to person's prototype. Person's prototype should say the name of the enemy. So enemy.prototype.sayName should return the hello, I am and name, but they're saying here enemy.prototype.sayName console log hahaha. So const Carol new player. So when we make Carol, for example, let's see how the chain goes. It goes to person and it creates it goes to player and creates a new player object with the name of Carol and the marker of X. Then after that it goes to this line where it exactly like references player.prototype. Instead of inheriting person.prototype's functions like hello, I am this name, it exactly like I lost it there, so I'm not exactly sure what happens there, but I'll probably read through this once again. After that, function enemy name, this dot name equals name and this dot marker equals, so enemy.prototype equals person.prototype. No, I tried to do it, but I lost the thread somewhere. If we had used object.set prototype of in this example, then we could safely edit the enemy prototype sayName function without changing the function for player as well. Alright. This will set player.prototype to directly refer to person.prototype, which could cause problems. Alright, and let's try to edit this out. Make this smaller, make it a wrap, make it a little bit bigger as well. Alright, so now we're watching the console, and what happens if, for example, we comment this for the enemy and uncomment this one and we save it. Unexpected identifier object, so I think we first had to do it the other way around. Do it for the player first. No, same thing. Oh, they're saying use, I'm sorry. So yeah, we can definitely check it out the other way around. I just had to remove the use. I don't need that. Alright. Carol.sameName is not a function, so Carol.sameName is not a function. Carol.sameName. I'm back. A new package arrived. He has self Christmas gift. What did you get? I'm curious. What did you get? Happy self Christmas then. Alright, let's uncomment this as well. And like, hello, I'm Caro. Yeah, this is initially what they what should have happened, but yeah, I don't fully get that example, to be quite honest. But anyways, we have a lot of reading, so I'm quite sure we'll be able to get it done. Read upon the concept of the prototype from the articles below. Read the article Understanding Prototypes and Inheritance in JavaScript from DigitalOcean. This is a good review of prototype inheritance and constructor functions, featuring some examples. I think it's called mattress in English. For sleeping? Mattress? Yeah, I believe so. That's very good. You have an even better night's sleep. Yes, perfect. Nice one. I ordered the new Mac Mini, the M4 Mac Mini, the base model, and it should come in a couple of days, and I'll be streaming from it. I have no patience for it to come. It's in Romania currently. Alright. To go a bit deeper into both the chain and inheritance, spend some time with JavaScript.info's article on prototypical inheritance. As usual, doing the exercise at the end will help cement this knowledge in your mind. Don't skip them. Important note, this article makes heavy use of Proto, which is not generally recommended. The concepts here are what we're looking for at the moment. We'll soon learn another method or two for setting the prototype. A MacBook, damn, that's fire, man. Yeah, it's not a MacBook, it's the Mac Mini. So Mac Mini M4, it's this one. I don't have like no cables for it, like everything uses just normal USB 2.0 and it's so C-type, so I'll have to get some hub or something, or adapters for it. But yeah, we'll be streaming from the Mac OS. Then you might have noticed the use of this keyword in object constructors and prototype methods in the examples above. JavaScript tutorials article on this keyword covers how this changes in various situations. Pay special attention to the pitfalls mentioned in each section and read the article Prototype versus Prototype in JavaScript. So quite a lot of reading. What was the second one? JavaScript.info. This is the second one. And demystifying. Alright, so they are in that order. Indeed, and then it happens as well to me. I also bought a new keyword. It's supposed to arrive tomorrow, but it's on delivery, so it comes today. Yeah, indeed. Every day I'm checking the tracking. I'm very impatient. I want the Mac Mini MacBook as well, but over here that's expensive as fuck. My current salary intake is not sufficient. I know it's also very expensive for me, but this one is it's $5.99 USD, so it's a very good price for the value you're getting for the output. Like it's I think it's about 2 to 3 times better than my current PC, and it's like that big for the fraction of what my PC originally costed. But my PC is now 9 years old, so it's crying for an upgrade. Alright, we have this Object.create method video by Texit. Go to the back, please. Provides another point of view on how to use Object.create to extend objects by setting the prototype. The first answer is the Stackoverflow question regarding defining methods via the prototype versus in the constructor. Okay. interactive Scrim, so we have quite a lot of resources. And check out this video. Okay, I hope this is not playing. No, it's not. Okay. In the explanation of this keyword from DevSage, that gives a different perspective on how its context changes, as well as scenarios in which this behaves unexpectedly. Okay, what are we learning in day 25? We're learning about JavaScript, prototypes, and constructors, objects, and so on. And I did another stream in the morning where we finished the last CSS project. So yeah, this for day 25. So it's a very neat upgrade. Yes, indeed. 9 years. It's been 9 years already. It served me good, but it's time for an upgrade by now. Alright, so I'm kind of tired from reading all that much, and we have quite a bit more to go, so I'm going to take a 10-minute break and I'll be right back with you guys. Thank you so much for watching me. 10 minutes and I'll be right back. Appreciate you so much. Be right back. Alright, I'm back. And we're ready to start diving into some of these articles and understand at a deeper level what prototype really is and the objects and the constructors. So 62, just 1 second. Alright, so first we're starting with this article from DigitalOcean. Let me remove all the sidebars because they're annoying. Oh, why is that like this big? I don't need this. Wow, I fucked up the article. So don't delete the contents. Is that it? No, I can delete them. I just deleted the wrong thing. Okay, also the header, I don't need it, thank you. This is cleaner. Alright, so we have understanding prototypes and inheritance in JavaScript. JavaScript is a prototype-based language, meaning object properties and methods can be shared through generalized objects that have the ability to be cloned or extended. This is known as prototypical inheritance and differs from class inheritance. Among popular object-oriented programming languages, JavaScript is relatively unique, as other prominent languages such as PHP, Python and Java are class-based languages, which instead define classes as blueprints for objects. In this tutorial, we'll learn what object prototypes are and how to use the constructor functions to extend prototypes into new objects. We'll also learn about inheritance at the prototype chain. So JavaScript prototypes. In understanding objects in JavaScript, we went over the object data type, how we create an object and how to access and modify object properties. Now we'll learn how prototypes can be used to extend objects. Every object in JavaScript has an internal property called prototype. We can demonstrate this by creating a new empty object. So we're making a new object and then we're getting the prototype of the empty object. Nice. This is the way we would normally create an object, but note that another way we can accomplish this with the object constructor. So let's new object. The double square brackets that enclose prototype signify that it is an internal property that cannot be accessed directly in code. To find the prototype of this newly created object, we'll use the getPrototypeOf method. And the output will consist of several built-in properties and methods. So we have constructor function, define getter function, define setter function, so on and so forth. Another way to find the prototype is through the proto property. Proto is a property that exposes the internal prototype of an object. It's important to note that proto is a legacy feature and should not be used in production code, and it is not present in every modern browser. However, we can use it throughout this article for demonstrative purposes. The output will be the same as if you had used getPrototypeOf. Okay, sure. It's important that every object in JavaScript has a prototype, as it creates a way for any two or more objects to be linked. Objects that you create have a prototype, as do built-in objects such as date and array. A reference can be made to this internal property from one object to another via the prototype property, as we'll see later in this tutorial. So prototype inheritance. When you attempt to access a property or method of an object, JavaScript will first search on the object itself, and if it's not found, it will search the object's prototype. If after consulting both the object and its prototype still no match is found, JavaScript will check the prototype of the linked object and continue searching until the end of the prototype chain is reached. At the end of the prototype chain is object.prototype. All objects inherit the properties and methods of objects. Any attempt to search beyond the end of the chain will result in null. In our example, X is an empty object that inherits from object. X can use any property method that object has, such as toString. Alright, so this is why you can use toString. Alright, this makes sense now. This prototype chain is only one linked. It's only one link long, so X to object. We know this because if we try to change two prototype properties together, it will be null. So we can chain prototype functions. You can get prototype of and then get prototype of as well. Sure. Let's look at another type of object. If you have experience working with arrays in JavaScript, you know that they have many built-in methods such as pop and push. The reason you have access to these methods when you create a new array is because any array you create has access to the properties and methods on the array.prototype. We can test this by creating a new array. Keep in mind that we could also write it as an array constructor. So the same way they made an object, they're now making an array. If we take a look at the prototype of the new Y array, we will see that it has more properties and methods than the X object. It has inherited everything from array.prototype. Array.prototype, okay, that seems familiar. So we have constructor function, concat function, pop, push, so on and so forth. You notice that the constructor property on the prototype, constructor property on the prototype that is set to array. The constructor property returns the constructor function of an object, which is a mechanism used to construct objects from functions. We can chain two prototypes together now. Since our prototype chain is longer in this case, it looks like Y to array to object. And by chaining prototype, you get the final object prototype. This chain is now referring to object.prototype. We can test the internal prototype against the prototype property of the constructor function to see that they're referring to the same thing. Alright, so understand what we did with the triple equals. We're just checking if I don't have the document anymore, but wait. So for example, where is it? I cannot find an example. Triple equals. No, I don't have it in the code. Alright, anyways. We can also use the isPrototype of method to accomplish this. So array.prototype is prototype of Y. It will return boolean true. Object.prototype is prototype of array, and again it will return true. We can use the instance of operator to test whether the prototype property of a constructor appears anywhere within an object's prototype chain. Alright, so even if it's not a direct prototype, that's at least how I understand it. If we say Y instance of array, it will check if the Y has any instance of the prototype array, and if yes, it will return true, even if it's not directly related. To summarize, all JavaScript objects have hidden internal prototype property, which may be exposed through Proto in some browsers. Objects can be extended and will inherit the properties and methods on prototype of their constructor. These prototypes can be chained, and each additional object will inherit everything throughout the chain. The chain ends with the object.prototype. Okay, So we after that have constructor functions, are functions that are used to construct new objects. The new operator is used to create new instances based off a constructor function. We have seen some built-in JavaScript constructors such as new array, new date, but we can also create our custom templates from which to build new objects. As an example, let's say we are creating a very simple text-based role-playing game. A user can select a character and then choose what character class they'll have, such as warrior, healer, thief, and so on. Since each character will share many characteristics such as having a name, a level, hit point, it makes sense to create constructor as a template. However, since each character class might have vastly different abilities, we want to make sure each character only has access to their own abilities. Let's take a look at how we can accomplish this with Prototypal Inheritance and constructors. To begin, a constructor function is just a regular function. It becomes a constructor when it is called on by an instance with the new keyword. In JavaScript, we capitalize the first letter of the constructor function by convention. The first letter of the constructor function, yeah, so 420, nice, thank you whoever subscribed, 420. Alright, so as I mentioned, I said I was thinking that when we create new constructors we can capitalize them, and they say that is true by convention. So what we're doing here is initialize a constructor function for a new hero with name and level. Alright, so we have created a constructor function called hero with two parameters, name and level. Since every character will have a name and a level, it makes sense for each new character to have these properties. The this keyword will refer to the new instance that is created, so setting this.name to the name parameter ensures that the new object will have a name property set. Now we can create a new instance with new, so let hero1, new hero, Bjorn, and level 1. If we console out hero1, we'll see a new object has been created with the new properties set as expected. So hero, name Bjorn, and level 1. Now if we get the prototype of hero1, we'll be able to see the constructor as hero. Remember, this has the same input as hero.proto, but this is the proper method to use. So for object.prototype of hero1, we get constructor, hero name, and level. You may notice that we've only defined properties and not methods in this constructor. It's a common practice in JavaScript to define methods on the prototype for increased efficiency and code readability. We can add a method to the hero using prototype. We'll create a greet method, so exactly what we did in the Odin project lesson so far. So they make a greet function on the prototype which returns the name of the character and says hello. Since greet is in the prototype of hero and hero1 is an instance of hero, so since greet is in the prototype of hero and hero1 is an instance of hero, this method is available to hero1, so it will inherit it. If you inspect the prototype of hero, you see greet is an available option now. This is good, but we want to create character classes for heroes to use. It wouldn't make sense to put all of the abilities for every class into the hero constructor because different classes will have different abilities. We want to create a new constructor function, new constructor functions, but we also want them to be connected to the original hero. We can use the call method to copy over properties from one constructor into another constructor. Let's create a warrior and healer constructor. So they're making a function warrior with name, level, and weapon, chain constructor with call. So this clicks. I remember this from Java when we used to chain constructors. So it will chain constructor with call to hero So this is kind of recursive, I guess. It will hero.co with this name and level, add the new property, this.weapon, so it will build up on this, on what we already have, this.spell. So I'm wondering now if when we make new heroes, like how do we make them? Do you make them like new warrior, new healer? Both new constructors now have properties of hero and a few unique ones. We'll add the attack method to warrior and the heal method to healer. So to the prototype they do attack function. Now what is the prototype of warrior? Is it like a whole separate thing from the hero.prototype? Warrior.prototype.attack function. The name attacks with the weapon. Healer prototype heal function. Name casts the spell. At this point we'll create our characters with the two new character quests available. Indeed, so we'll create a warrior with the new warrior and then give it the weapon name, and the healer we'll create with new healer and give it a spell name. Hero 1 is now recognized as a warrior with the new properties. We can use the new methods we set on the warrior prototype. So hero attack, but what happens if we try to use methods further down the prototype chain? So hero 1 greet, uncalled type error, hero 1 greet is not a function. Prototype properties and methods are not automatically linked when you use code to chain constructors. We'll use Object.setPropertyOf to link the properties in the hero constructor to the warrior and healer constructors, making sure to put it before any additional methods. Alright, before any additional methods, but they should have left some code below or at the top to make more sense of it, because object set prototype of warrior.prototype to hero.prototype, so it can inherit what hero.prototype already has, but all other prototype methods added below. So you're saying we should make it where exactly? Yeah, I'm not sure. Before any other prototype methods added below. Anyways, now you can successfully use prototype from hero on an instance of a warrior or healer. So hero 1 greet. Here is the full code for our character creation page. Alright, so they're doing that. They first make the hero, then the warrior, then the healer. Alright, that makes sense. And link prototypes and not prototype methods, so they link it before that and then create the new prototype functions. Alright, sure, that makes sense. So we first link them, and from then on they start like tracking what new functions you make. Initialize individual character instances, right, sure. So with this code we've created our hero constructor with the base properties, created two character constructors called warrior and healer from the original constructor, added methods to the prototypes and created individual character instances. JavaScript is a prototype based language and functions differently than the traditional class based paradigm that many other object-oriented languages use. In this tutorial we learn how prototypes work in JavaScript and how to link object prototypes and methods via the hidden prototype property that all objects share. We also learned how to create custom constructor functions and how prototype inheritance works to pass down property and method values. Perfect. Alright, so we've gone through this article. It was quite extensive and very fun. I like how they made the analogy with the game, and it was really fun and easy to understand that way. Perfect, so we're done with that, and we're moving over to prototypal inheritance. Let me again get rid of the sidebars. Oh, I can actually just... No, I can't. Just 1 second, I'm still here, just 1 second. Alright, I'm here. I just cleaned up the page so it's easier to read. And let's see what we have on here. It is by JavaScript.info, Prototypal Inheritance. In programming, we often want to take something and extend it. For instance, we have a user object with its properties and methods. We want to make admin and guest as slightly modified variants of it. We like to reuse what we have in user, not copy re-implement its methods, but just build a new object on top of it. And prototypal inheritance is a language feature that helps in that. Prototype in JavaScript objects have a special hidden property prototype as named in the specification that is either null or references another object. That object is called a prototype. When we read a property from object and it's missing, JavaScript automatically takes it from the prototype. In programming, this is called prototypal inheritance, and soon we will study many examples of such inheritance, as well as cooler language features built upon it. The property prototype is an internal and hidden, but there are many ways to set it. One of them is to use the special name proto like this. Sets a rabbit.prototype equal to an animal. Alright, now if we read a property from rabbit and it's missing, JavaScript will automatically take it from animal, for instance. Here the line with the asterisk sets animal to be a prototype of rabbit. Alright, then when alert tries to read property rabbit.eats, it's not in rabbit, so JavaScript follows prototype reference and finds it in animal. Look from the bottom up, so rabbit jumps true, prototype eats dot true. Here we can say that animal is a prototype of rabbit, or rabbit is prototypically inherits from animal. So if animal has a lot of useful properties and methods, then they become automatically available in rabbit. Such properties are called inherited. If we have a method in animal, it can be called on rabbit. So let's say walks, we can say rabbit.walk, and it will alert animal walk. This method is automatically taken from the prototype like this, so it goes into the prototype, accesses walk. The proto chain can be longer, so we have animal, rabbit, and long year. So we make, we start with animal, we say walk there and it's true. Then after that, rabbit jumps through proto is animal, and the long ears proto is a rabbit. So long ear.walk, it will search in long ear for walk, it will not find it, it will go to rabbit, it will not find it, and it will finally find it in animal. So this is exactly how it's depicted. Ear length, then jumps through, so on and so forth. It goes from long ear to rabbit to animal. Now if we read something from long ear and it's missing, JavaScript will look for it in rabbit and then in animal. There are only two limitations. The references can't go in circles. JavaScript will throw out an error if we're trying to assign proto in a circle. The value of proto can be either an object or null. Other types are ignored. Also, it may be obvious, but still there can be only one prototype. An object may not inherit from two others. Alright, proto is a historical getter setter for prototype. It's a common mistake of novice developers not to know the difference between these two. Please note that proto is not the same as the internal prototype property. It's a getter setter for prototype. Later we'll see situations where it matters. For now, let's just keep it in mind as we build our understanding of JavaScript language. The proto property is a bit outdated. It exists for historical reasons. Modern JavaScript suggests that we should use Object.getPrototypeOf and Object.setPrototypeOf functions instead that get set. We'll also cover these functions later. I didn't understand what is written here. The specification proto must only be supported by browsers. In fact, though all environments including server-side support proto, so we're quite safe using it. As the proto notation is a bit more intuitively obvious, we'll use it in the examples. Writing doesn't use prototype, so the prototype is only used for reading properties. Write, delete operations don't work directly with the object. In the example below, we assign its own walk method to rabbit. Okay, and it's true that we've set the rabbit's prototype to animal, but it will first search for walk in the rabbit object, and if it finds it, it will alert it. If not, then it will go to animal. So that makes perfect sense. From now on, rabbit.walk call finds the method immediately in the object and executes it without using the prototype. As accessor properties are an exception, as assignment is handled by a setter function, so writing to such a property is actually the same as calling a function. For that reason, admin.fullname works correctly in the code below. So let's see, we have user, name, surname, set, full name, value of this.name and this.surname with a value.split. So it will set the full name to John Smith, and get full name, it will return again this.name, this surname, John Smith. So what they're saying, admin.fullname, so let admin, proto is user, is admin true. So when we alert admin.fullname, we get John Smith. I think because the full name is not found in admin, so it moves on to the user, and I guess it's not directly a function, but we have, oh no, it is a function. So we set and get admin.fullname, Alice Cooper, admin.fullname. We can also modify it. But then, wait. State of user protected. So, we can modify it on the certain object, but that will not modify it on the user object where this is initially, like, how do you say it, defined. Thank you whoever subscribed. I didn't see, but 2 subscribers. Thank you so much, guys. Really appreciate it. I guess they'll explain it here. So the line with the asterisk, the property admin.fullname has a getter in the prototype user, so it is code. And in the line with the 2 asterisk, the property has a setter in the prototype, so it's code. So so when we try to access something, the getter is code, and when we try admin.fullname and try to set it to something, the setter is code. That is really interesting. This is very smart as well, very interesting. Alright, so the value of this, an interesting question may arise in the example above. What's the value of this inside set full name value? Where are the properties this.name and this.surname written into user or admin? The answer is simple. This is not affected by prototypes at all, no matter where the method is found in an object or its prototype. In a method call, this is always the object before the dot. The object before the dot refers to admin, for example. See, it's before the dot. Okay, so the setter admin.fullname uses admin as this and not user. This is actually a super important thing, because we may have a big object with many methods and have objects that inherit from it, and when the inheriting objects run the inherited methods, they'll modify only their own states, not the state of the big object. For instance, here animal represents a method storage and rabbit makes use of it. The call rabbit.sleep sets this is sleeping on the rabbit object, I guess to true. We have animal again with walk. If this is sleeping, alert I walk. So if the rabbit is not sleeping, alert I walk, and we have sleep, this is sleeping to true. We set the proto to animal, name white rabbit, and modifies the rabbit is sleeping, so we toggle on the sleep and alert rabbit is sleeping to true. Then animal is sleeping, undefined, no such property. So when we do this is sleeping to true, we set it for the rabbit, and then we try to check if the animal is sleeping, but it is undefined. We haven't gone into that function at all. Alright, makes sense. If we had other objects like bird, snake, etc. inheriting from animal, they would also gain access to methods of animal, but this in each method call would be the corresponding object evaluated at the call time before the dot, not animal. So when we write that data to this, it is stored into these objects. As a result, methods are shared, but the object state is not. For in loop, the for in loop iterates over inherited properties too. For instance, we have animal is true, a rabbit jumps through, proto is animal, okay. Alert object.keys of rabbit, and it will print out the keys, which is only one, it's jumps. And for in loops loop over both own and inherited keys. So for let prop in rabbit, so properties in rabbit, alert prop. So for every property that a rabbit has, it iterate over it and return it, alert it actually. So it will alert jumps, and then it will alert eats as well, because those are all the available properties the rabbit can use. Interesting, okay. If that's not what we want and we'd like to exclude inherited properties, there is a built-in method object.hasOwnProperty key. It returns true if object has its own not inherited property named key, so we can filter out inherited properties or do something else with them. In this case, for let prop in a rabbit, let is on rabbit.hasOwn property prop, it will check if that property is owned by the rabbit, and if it is, it will alert the our and then the property, and else if it's not the rabbit's, it will alert inherited and then the property. Here we have the following inheritance chain. A rabbit inherits from animal, that inherits from object.prototype because animal is a literal object, so it's by default, and then no above it. So we have rabbit jumps, prototype of that is animal with eats, and the prototype of animal is object, and above object there is like nothing above object. Note there is one funny thing. Where is the method rabbit.hasOwn property coming from? We did not define it. Looking at the chain, we can see that the method is provided by object.prototype.hasOwn property. In other words, it's inherited. But why does hasOwn property not appear in the foreign loop like eats and jumps do for in lists inherited properties? The answer is simple. It's not enumerable. Just like other properties of object.prototype, it has enumerable false flag, and foreign only lists enumerable properties. That's why it and the rest of the object.prototype prototype properties are not listed. Cool, very interesting. Almost all other key value getting methods ignore inherited properties, such as object.keys, object.values, and so on, ignore inherited properties. They only operate on the object itself. Properties from the prototype are not taken into account. So we have the summary here, and we have some tasks as well. In JavaScript, objects have a hidden prototype property that's either another object or no. We can use object.proto to access it. The object referenced by prototype is called prototype. No shit, Sherlock. If we want to read a property of object or call a method and it doesn't exist, then JavaScript tries to find it in its prototype. Write delete operations act directly on the object. They don't use the prototype, assuming it's data property, not setter. If we call object.method and the method is taken from the prototype, this still references object, so methods always work with the current object even if they are inherited. The foreign loop iterates over both its own and inherited properties. All other key value methods, key value getting methods, only operate on the object itself. So this is quite the summary, and we have a few tasks here. Here is the code that creates a pair of objects, then modifies them. Which values are shown in the process? So we have animal and rabbit. Jumps through. Prototype of rabbit is animal, so we alert rabbit.jumps. This will be no. Delete rabbit.jumps. Alert rabbit.jumps. I guess undefined. And from delete rabbit. I guess the second alert will be undefined. I'm not sure. The first one will return no. The second one may be undefined because there will be no wait, sorry for that. I forgot to see. No, I didn't forget to see, but I didn't saw that they both have jumps method. So the first one will be rabbit.jumps. This will be true. Then if we delete that, if we get rid of that, it will go into the prototype, so it will get the one from animal and will alert rabbit.jumps, it will get no. And the third time when we remove it from here as well, I guess it will return undefined. So true, no, and undefined. Sure, we got that right. That's very good. Searching algorithm. The task has two parts. Given the following objects, so you have head, glasses 1, table, pen 3, bed, we have sheet 1 and pillow 2. Let my pockets, let pockets money 2000. Use proto to assign prototypes in a way that any property lookup will follow the path pockets, bed, table, head. For instance, pockets.pen should be 3 found in table. Alright, and bed.glasses should be 1 found in head. So we have to make where is it now? Answer the question. Answer the question, is it faster to get glasses as pockets.glasses or head.glasses? Benchmark if needed. I don't know how to benchmark that, but let's think now. Should we благодаря. Should we start by making pockets the main prototype? No, I think we should make head the main prototype. So we'll set tables prototype to head, we'll set beds prototype to table, and pockets prototype to bed. Then we would be faster to access glasses, so glasses from pocket.glasses or head.glasses. It will be head.glasses because that's directly inside of it. So let's see the solution. Let's add proto. So proto head, indeed, we'll make tables prototype head, then we'll make beds prototype table, and pockets prototype bed. Indeed, so pockets.pen, this is 3, and bed.glasses 1, table.money is undefined, table.money, yeah, because it cannot move down, it can only move up, I think. In modern engines, performance-wise, there is no difference whether we take a property from an object or its prototype. They remember where the property was found and reuse it in the next request. This is very interesting, very cool. I thought that glasses in the head would be faster. For instance, for pockets.glasses, they remember where they found glasses in the head, and next time they'll search right there. They're also smart enough to update internal caches if something changes, so that optimization is safe. Perfect. Where does it write? We have rabbit inheriting from animal. If we call rabbit.eat, which object receives the full property, animal or rabbit? What do you mean the full property? So we have animal eat, this dot full, the rabbit. The answer is indeed the rabbit. That's because this is an object before the dot, so rabbit.eat modifies rabbit.full. So property lookup and execution are two different things. The method rabbit.eat is first found in the prototype, then executed with this equals rabbit. Why are both hamsters full? We have two hamsters, speedy and lazy, inheriting from the general hamster object. when we feed one of them, the other one is also full. Why and how can we fix it? So let's see now. We have a hamster of stomach and it's an array and eat food. This dot stomach dot push food. So both of them, speedy and lazy, the prototype is hamster. This one found the food, so speedy.eat apple, alert speedy.stomach apple. This one also has it. Why? Fix please. Alright. So they have stomach in the hamster properties. They don't have any properties of their own. They can access eat with food, and this dot stomach dot push food. So it will be, for example, speedy dot eat apple. It will go into speedy. There is no eat property, so it will move on to hamster, and it will trigger with apple, and it will say speedy dot stomach dot push food. Now, why is lazy stomach also full, also with apple? That is quite interesting. This one also has it. Why? Fix please. This is an interesting question. Lazy dot stomach, it will go into lazy. It somehow filled the stomach for the entire hamster object, not for speedy only. But why does it do that? I have no idea. I'm going to look at the solution. I have no idea, guys. Let's look carefully at what's going on in the code. So speedy.eat apple. First, the method speedy.eat is found in the prototype hamster, then executed with this equals speedy, the object before the dot. Alright, then this dot stomach dot push needs to find stomach property and call push on it. Alright, looks for stomach in this speedy but nothing found. So we don't have stomach in speedy or lazy, so I guess it will not find it, and it will follow the prototype chain and find stomach in hamster. Then it goes push on it, adding the food into the stomach of the prototype. So every hamster instance should have a stomach of its own, it seems like. So all hamsters share a single stomach. That makes sense, because if, for example, you had different persons and in the human class you had the name, then every person will share one name. Then it's kind of the same. They also need to have everything that's unique about them. They should have it in their own properties, I guess. Both for lazy.stomach.push and speed.stomach.push, the property stomach is found in the prototype, as it's not in the object itself. Then the new data is pushed into it. Please note that such thing doesn't happen in case of a simple assignment this.stomach. Please note that such thing doesn't happen in case of a simple assignment this.stomach equals food assigned to this.stomach instead of this stomach push. So this dog stomach equal the food, it will make them a stomach, or now all works fine because this dot stomach equals does not perform a lookup of stomach, the value is written directly into this object. Also, we can totally avoid the problem by making sure that each hamster has their own stomach. Yeah, so this is the solution I got, but this looks like a cleaner way of doing it, let's say. This is more readable and human friendly. As a common solution, all properties that describe the state of a particular object, like stomach above, should be written into that object. That prevents such problems. Alright, sure. We're done with this one as well. Pretty good. And next we have demystifying the JavaScript this keyword. Okay, after that we have one more article. Sure. Okay, let me just sip some water. One second and I'm starting. All right. So let me get rid of the sidebars that are making them money, but I don't like them. Sorry, I don't like your sidebars. And the header. And this one, secondary. Alright, so we have, let me zoom in a little bit, demystifying the JavaScript this keyword. So summary, in this story you'll learn about the JavaScript this value and understand it clearly in various contexts. If you have been working with other programming languages such as Java, C# or PHP, you're already familiar with this keyword. In these languages, this keyword represents the current instance of the class and it's only relevant within the class. JavaScript also has this keyword, however, this keyword in JavaScript behaves differently from other programming languages. In JavaScript, you can use this keyword in the global and function contexts. Moreover, the behavior of this keyword changes between strict and non-strict modes. What is this keyword? In general, this references the object of which the function is a property. In other words, this references the object that is currently calling the function. Suppose you have an object counter that has a method of next. When you call the next method, you can access this object. Okay, so counter.next, and it will go into counter into the function and return counter plus counter.count. So it will make the counter 1. I'm back, successfully managed to create an Arch Linux installation on a USB. Wow, nice. So when you're saying that, is it like you can plug in the USB and you can boot from the USB and still with the reading? Yeah, indeed. Then you can boot from the flash drive and you install Linux from there, or you can use it directly and it will remember everything on the flash drives. Which one is it? Arch Linux. I'm using the Ubuntu, the default one. I thought it will be easiest. Alright, inside the next function, this references the counter object. See the following method call, so counter.next. The next is a function that is the property of the counter object, therefore inside the next function this references the counter object. I use X Ubuntu. I think there are like tons of different variations of Linux. I think you can even make your own. So global context, in the global context, this references the global object which is the window object on the web browser or global object on Node.js. I used to use Ubuntu as well, but I want to try something else. Yeah, definitely. But tell me, can you, like, how does it work? You stick the USB into the computer and you can boot from there, and all the memory that you're using is saved on the USB, or what is the case with that? Or you just install it from there? This behavior is consistent in both strict and non-strict modes. Here is the output on the web browser. So console log this equals window. So this is like the global, this equals to the window object. If you assign a property to this object in the global context, JavaScript will add the property to the global object as shown in the following example. This.color will be equal to window.color. Alright, we have function context. In JavaScript, you can call a function using the following ways. You have function invocation, method invocation, constructor invocation, and indirect invocation. Each function invocation defines its own context, therefore this behaves differently. Simple function invocation in the non-strict mode, this references the global object when the function is called as follows. So we have function of snow, and when we console log this triple equals window, it's true. Show, not snow, sorry. So we have function show console log this equals window. Yeah, this is the window. Okay, when you call the show function, this references to the global object, which is the window on the web browser and global on Node.js. Calling the show function is the same as window.show. In this, alright. Yes, you insert the USB and boot from it by going into your BIOS and changing the boot order. After it boots from drive, you see an installation UI to start the installation. Right, yeah. I did that also on this. What is it? I did it on this USB, but let me autofocus and show you the other one, because the other one is more interesting. How does it focus? There you go. This is the one I have Linux on, but this one is more interesting. As you can see, you can take it out. That's not how it's meant to be, but you can take out the entire like motherboard and stuff. I use this one for movies. Alright, so in the strict mode, JavaScript uses this keyword inside a function to undefined. For example, use strict. I don't know what strict mode is, to be honest. Console log this triple equals undefined. To enable the strict modes, use the directive use strict at the beginning of the JavaScript file. Oh, I never knew that. If you want to apply the strict mode to a specific function only, you place to the top of the function body. Note that the strict mode has been available since ECMAScript 5.1. The strict mode applies to both function and nested functions, for example. So the output true and true, so it will be true for everything nested inside of the show, it seems like. In the displayer function, the this is also set to undefined as shown in the console. Alright, this is very how do you say it? I don't quite understand it, to be honest with you, but we'll get to it. Method invocation. When you call a method of an object, JavaScript sets this to the object that owns the method. See the following car object. So we have a car, brand Honda, get brand function will return this brand. So console log car .getBrand, obviously it will return the Honda. Okay. In this example, the this object in the getBrand method references the car object. Since a method is a property of an object which is a value, you can store it in a variable. Let brand equals car.getBrand. Okay, and then you can call the method via the variable. So console walk brand undefined. You get undefined instead of Honda because when you call a method without specifying its object, JavaScript sets this to the global object in a non-strict mode and undefined in the strict mode. To fix this issue, use the bind method of the function prototype object. The bind method creates a new function whose this keyword is set to a specific value. So let brand equals to car.getBrand.bind to car and console walk. I don't know how exactly this relates to this because this is just like a variable, it's not a function that we can call. Am I missing something? I'm not sure. These examples, I feel like they start off really easy and then they get out of I don't know, they get really complicated really fast is what I'm trying to say. In this example, when you call the brand method, this keyword is bound to the car object, for example. So let brand equals car get brand, so get brand bind to bike, so it will not go into the car brand but the bike's brand, and to output Harley Davidson. Okay, in this example the bind method sets the this to the bike object, therefore you see the value of the brand property of the bike object on the console. So it will go car.getBrand, so it will call this function and this bind to the bike sets this to bike, so it will return bike.brand, which is Harley Davidson. Right, so I understand this at least a little bit. Constructor invocation. When you use the new keyword to create an instance of a function object, use the function as a constructor. The following example declares a car function and then invokes it as the constructor. So indeed they make a function car with a brand you pass, and then car prototype.getBrand, return this brand. So this is on the prototype, not on the car object directly. So you make a new car with Honda, but you can use car.getBrand, although it is not defined directly inside of it. The expression new car Honda is a constructor invocation of the car function. JavaScript creates new object and sets this to the newly created object. This pattern works great with only one potential problem. Now you can invoke the car as a function or as a constructor if you omit the new keyword as follows. So var BMW car BMW console walk BMW.brand. Type error cannot read property brand of undefined, so BMW, if you omit the new keyword, you cannot use it as a constructor. Since this value of the car sets it to the global object, since this value in the car sets it to the global object, the BMW brand returns undefined. This value in the car. So it still goes into the BMW. If I'm correct, it goes into the car like constructor, but this in that case is set to the global object, so this .brand is undefined instead of passing this. Alright, I kind of get it. To make sure that the car function is always invoked using the constructor invocation, you add a check at the beginning of the car function as follows. If this instance of car, so if this is not an instance of car, thrower must use the new operator to call the function. ES6 introduced a meta property named new.target that allows you to detect whether a function is invoked as a simple invocation or as a constructor. You can modify the car function that uses the new.target meta property as follows. Function card if not new.target, thrower must use the new operator, so new.target. That's interesting. I get it so and so. Indirect invocation in JavaScript. Functions are first class citizens. In other words, functions are objects which are instances of the function type. The function type has two methods, call and apply. These methods allow you to set this value when calling a function. For example, we have a function getBrand of prefix, console prefix plus this brand, so you get like it is a Honda, it is a Audi, so on. So we make Honda and Audi as objects with brand Honda and brand Audi, and when we get brand.call, so we go into here and call Honda. Wait, so we get brand with a prefix and console walk prefix. Yes sir, as Supreme said, it's not that difficult. The same practically if you installed Linux distro, but it will be better with a good USB. I use one of 128 gigabytes. Yeah. Alright, so you have quite a bit of space on that USB. And what happens if you like take out the USB while you're working on the Linux? I'm just curious. Output, it's a Honda, it's an Audi. In this example, we call the getBrand function indirectly using the call method of the getBrand function. We passed Honda and Audi object as the first argument of the call method, therefore we got corresponding brand for each call. Everything fails. Personal experience, so you've tried it before. That's like deleting system32 in your C folder. Probably not that bad, but yeah. The apply method is similar to the call method, except that its second argument, it's an array of arguments. Get Brian Honda. Alright. Yeah, not by wanting to do so, I forgot it was on the USB. I feel you. Try to stick it on the back of the computer if you have ports there, so there is no possibility of taking it out. Alright, arrow functions. I know think a little bit about this. So ES6 introduced a new concept called the arrow function. In arrow function, JavaScript says that this lexically. This means the arrow function does not create its own execution context, but inherits this from the outer function where the arrow function is defined. See the following example. So you have let of get this, which is an arrow function, and console walk get this equals to window. So get this will return this, which is the window. In this example, this value is set to the global object. To the window in the web browser. Since an arrow function does not create its own execution context. Defining a method using an arrow function will cause an issue. For example, function car this speed, car prototype get speed, have var car of new car, console car dot get car speed, so it will go into car dot get speed. It is undefined because wait, why is it undefined now? So it will make a new car. The car speed will be 120, and then get speed is not in this car, so it will go into the prototype, get speed, return this dot speed. Since an arrow function does not create its own execution context, defining a method using an arrow function will cause an issue. So don't use an arrow function when with the prototype. Is what I'm getting. Inside the getSpeed method, this value reference the global object, not the car object, but the global object doesn't have property called speed, therefore this speed in the getSpeed method returns undefined. Alright, so we're done with that article. This one is not that long, so we can probably go through it, and the other one should be pretty easy to go through as well. Alright. So let's start with this one. It's about prototype versus prototype in JavaScript, or .prototype. Why are there so many types of prototypes in JavaScript, and what do they all do? It may seem very daunting when you start learning about prototypes in JavaScript. A lot of the confusion stems from the fact that there are two different prototypes in JavaScript that refer to different concepts. Let me explain. Prototype in brackets is a hidden private property that all objects have in JavaScript. It holds a reference to the object's prototype. An object's prototype is the object that an object inherits or descends from. In the following diagram, the object son descends from father, so father is the prototype of son. That means the hidden prototype property of son points to father. Alright, to summarize, prototype is a hidden property that references an object's prototype. An object's prototype is the object that an object descends or inherits from. So that was thank you whoever subscribed, really appreciate it. So that was the prototype with the braces or the brackets actually, and then we have proto with underscores, also called the dunner or dunder proto or double underscore prototype is a property of Object.prototype. More on that in a minute. That exposes the hidden prototype property of an object and allows you to access or modify it. You should not use it as it's deprecated, although you may come across it in older code. The modern way of accessing an object's prototype is by using Object.getPrototype of object. You can also modify an object's prototype using Object.setPrototype of object, and then the prototype you want to set it to, as you can see in the following example. Alright, to summarize, proto is a method that exposes the hidden prototype property and allows you to modify it. Object.getPrototype of and Object.setPrototype of are the modern way of getting access to and setting an object's prototype. We have prototype with a dot. It's a special property that almost all functions have that is only used when a function is invoked as a constructor function. I say almost all because arrow functions and methods defined using the concise syntax do not have a.prototype properties and cannot be used as constructors. The prototype property contains a reference to an object, and when a constructor is used to instantiate or create a new object, .prototype is set as the prototype of the new object. A constructor function is like an object factory that creates new objects which are instances of itself. What is a constructor function? This is a separate article we're not going to go through, but for example, when the constructor object factory is used to instantiate a new object referenced by the variable obj on line 5 of the following code, object's hidden internal prototype property now holds a reference to the same object that is referenced by the object factory.prototype. This means that any properties or methods defined in object factory.prototype are accessible by obj. Object factory.prototype is prototype of object. Alright, so here on line 7 we prove that object.factory.prototype references an object. On line 8 we prove that object factory.prototype is the prototype of obj. So obj's prototype is new object factory. Accessing a prototype's properties. So we have object factory.prototype.prop equals I'm a property of object factory's prototype, and this is a continuation of the previous code block. Okay. Console.walk to obj is object factory property. Hi, I'm a property. Console.walk obj prop is I'm a property of object factory.prototype. Sure. Notice that on line 10 we add a property called prop to the object referenced by object factory.prototype. Remember that object's prototype property references the same object as object factory.prototype. We can see it on line 12 that obj does not have a property called prop. It only has one property called property. However, obj can access prop on line 13 because it inherits the properties of its prototype, which we know is the object references by object factory prototype. So, to summarize, prototype is a special property that all functions have that comes in a reference to an object that contains a reference to an object, When a constructor is used to instantiate a new object, constructor name.prototype is set as the prototype of the new object. All instances of that constructor, the objects it creates, can access the properties of constructor name.prototype. I briefly mentioned object.prototype earlier in the article. Object is the built-in constructor function that almost all objects in JavaScript are instances of, and therefore almost all objects inherit from the object referenced by the .prototype property, object.prototype. I hope this article finds you well, so on and so forth. So we're done with that, and we have a video to watch. It's on Object.create method, and it's 7 years ago, so that will be interesting. Let's see what they say. I'll have to find my headphones for this one. Okay. That is quite challenging, not going to lie. And still not quite there. There you go. Alright, let's make sure there is sound, and let's learn about Object.create.
Text tutorials. Today we are going to learn about a very important method in JavaScript called Object.create. Object.create makes the prototype inheritance possible in JavaScript. And this tutorial is part of a much larger series in object-oriented programming. So if you haven't started from the beginning, you can do so by clicking on a link here. I'll provide it here. Now every object in JavaScript is created from this master object. And the name of this object is object. And it has a capital O, as you can see. So whenever I say object with capital O, which means I'm referring to this master constructor. Now, if I want to look at it, what it is, it's in a global space, so I can use it directly. And I can just simply say console dir. So dir would help me look at this object, master object, in detail. I would see a function. As I said, it's a constructor, which is a function. And if I expand it, I would see a bunch of method object has. One of the methods is create. So this is what we're going to look at it, create method. It also has other methods that you can use on it. But today we are going to simply talk about Object.create method. Now let's look at the syntax of this method Object.create. It would take two arguments. The first argument is some sort of object prototype. So it will be object. And the second argument is some sort of property object. The second argument actually is optional. So using this, let's create a new object. So I'm going to call this object my object. So const my object, object.create, and I'm going to set using object's prototype, the master object's prototype. And remember, every constructor has a property called prototype, which holds a bunch of methods. So I'm going to use object's prototype to create this my object. And if I examine it using console, I would see, so I have an object, and again, here's a reference. Proto underscore underscore proto underscore underscore is nothing but its creator, and which will point to that object's prototype. So if I look at it, I would see all these methods, and I can verify if these are the exact methods that is in object's prototype. If I do, let's say, console object and run both. So the first one is the my object, and it has a proto, and
I think
which
it has fewer
bunch of
options
methods.
there.
And this is the object constructor. And if I scroll down, it also has prototype, and it also has a bunch of methods. Constructor has property, is prototype of, which are the same methods.
So they're the one inside.
So basically, it's
The
the same
keyboard has
pointer.
arrived. Yo, you got a lot of stuff today. A matrix keyboard, nice. What keyboard do you have?
To this object.
Nice one.
prototype.
It's a happy
now,
day
remember
for
when
you.
you create an object literal,
Is the our X EPU Maker F75? Never heard of that. Let me check. Is it mechanical? Oh my god, it's a small one. Nice. And it still has the arrow keys. Oh, that's very neat, because I want to get a small keyboard myself without the numpad, but I was wondering, like, what do you do with the arrow keys? Like, I still need the arrow keys and the page up, page down, delete, so on and so forth. But that is actually a really neat solution. Wow. Damn, that's sick, man. How much is that? $70. Nice. Indeed, and it sounds so good. Nice. Fuck, this is really cool, and it seems chunky too. Oh, I like this one. Hell yeah, this is a nice ass keyboard. Good job. I'll have to write this down somewhere. Is it wireless also? Tell me if it's wireless, because I need a wireless one. Wait. Mechanical keyboard. Yeah, it is. Holy shit. It connects via Bluetooth, right? Because for the MacBook I don't want $62. Nice, you got it a bit cheaper. Indeed, it's wireless. Because for the Mac Mini I need a wireless keyboard and mouse, because I don't want the wires all sticking out everywhere. So I'm looking for a new keyboard, and this one is very good. Nice one, nice purchase there.
so we can say const literal. It's an empty
Damn, good
literal.
for you.
Now this actually also is created
Wired
using the
and
Object.create
wireless.
method.
So you have an optional wire, or I guess it's to charge it. Nice, that's so cool.
Internally, so we'll have a prototype set to
Your second mechanical keyboard. I've never had a mechanical keyboard. I don't know how it will sound on stream though, because this already is kind of annoying, and if it was mechanical, I don't know if it will be better for you guys or it will be worse. So I'm thinking of either a silent keyboard or like a mechanical keyboard. I don't know which one will be better. We'll see.
Objects prototype, and I can examine it.
It sounds
by-
stocky. Nice.
I would see exactly the same prototype reference
Silent
here. Now you don't always have to
So it's not
set
that
this
loud.
reference. You can create object without the object prototype. You can say const no proto. I'm just gonna call this object's name, and you can say object.create, and I'm just gonna pass null to it, which means don't set any
Perfect. Nice.
prototype. And if I examine it, I would see three objects:
I'll check
my
out
object,
some
my literal, and
Reviews.
no proto. And you can
YouTube
see
videos.
the first two have reference to prototype, and the second one has no.
It
First,
has no prototypes. Why is that now? Create
if I examine
now.
it, I would see three prototype.
Sure.
And if I examine it,
prototype with the
I would see
create.
three objects: my object, my literal, and no proto.
Okay.
And I can see the first two have reference to prototype, and the second one has no properties at all, so it doesn't set the reference to object prototype. Now, one of the jobs of Object.create is to create objects, right? As we see, we are using objects prototype. But what if I create a new constructor? So let's create a constructor called car. So I'm just going to say const car, and it's nothing but a constructor. You can say, and inside it would say this dot color. Now you can actually create, because it's a constructor, you can create cars from it. So let's say if I create car1 equal to new car, and I'm just gonna pass red color. So this is how I create a new car. I can do the same thing with objects.create. Const car2 object.create, and I'm just going to use this car's prototype. The only difference is here in the first example I'm running the constructor, and the second one I'm not running the constructor. So the difference between two is it's not going to set the initial property that constructor usually set. So if I console log out,
If you not set the color.
Why people say that 42 Heilbronn is too good to be true. Hi, my name is Albina.
Sorry for this
so the first car
advertisement.
has the color property, and the second car doesn't. But again, they are setting to the same reference for the prototype. Now, besides creating objects, the main objective of Object.create method is to extend constructors. You know how in object-oriented programming languages, you have a base class which has some methods, and you can create a subclass which would inherit the base class methods. So you would use something like class B extends class A, and it would basically copy all the methods into class B. Similarly here, you can extend one constructor from another constructor. So let's start with a car constructor, and I'm going to add a prototype, a method to it. So I can say car.prototype. I'm going to create this method called getColor. Let's say getColor, and inside it would just say return this dot color. And remember, this is a new ES 2015
Very new.
syntax. You don't have to say getColor equal to function. Now
Well, that was
let's
7 years
create
ago.
a toy car.
W.
So, which will be another constructor. So I'm just going to say constant toy car equal to a function. This one is an empty constructor. It doesn't have anything. Now what I want is toy car to have all the car's properties and methods. So basically, using the prototype inheritance, I want to set toy car's proto to be cars proto. And you can do it using the Object.create method. So the way you would do it is say toy car dot proto type equal to, and here I would pass car dot. So basically this will set a reference for the toy cars proto to cars proto. So let's say if I create an object using this toy car constructor. So I can say Lego car equal to new toy car. And if I look at this Lego car, I should see the prototype reference. So I look at the toy car and expand it.
It's the object.
I would see the get color method, which is coming from the car constructor. There are a bunch of ways to verify if toy car is extended from. One method is I would just say Lego car instance of. This should give me true, because is Lego car instance of toy car, which is correct. So if I run it, I would get it true. You can also check if
instance of
Lego car is instance of car. So they both are true. And since car is actually created from object, because it's inheriting objects, the master objects properties, so you can also verify if Lego car is an instance of the master object. If I run it, all three are true. There's also another method called is prototype of.
Prototype of, yeah, that's what I was thinking.
Prototype of Lego car. So this should give me true. So is toys car prototype is prototype of Lego car, and that should be true. I would get it true.
Okay.
Similarly, is car's prototype is prototype of toy car, that should be true as well. Is object's prototype is prototype of Lego car, that is also true. So in nutshell, Object.create
so it's not the direct prototype, but every prototype it has.
Helps you extend a constructor.
That's good to know.
Compared to classical inheritance, when you extend one class from another, you basically copy all the methods from the base class into subclass. Here, you just set a reference from subclass to the base class. So it's a prototype reference, so you don't really copy anything. In the next tutorial, we are going to look at prototype chain. And I hope you learned something from this tutorial. And if you did, please like, subscribe, and provide a constructive comment. Thank you.
Alright. What was that for? Object.create provides another point of view on how to use Object.create to extend objects by setting the prototype. The first answer was Stackoverflow question regarding defining methods via the prototype versus the constructor, explains when you may want to use one over the other. So this is the answer. I'm just going to go to the bathroom really quick, and I'll be right back because I'm going to pee myself. I'll be right back. Okay, I'm back. I think we have just a little bit more to cover. This is the answer from the Stack Overflow they wanted us to read. So let's see what it is. Maybe can I zoom it in for you guys? Yep. Alright, so they're saying wait. Declaring JavaScript object method in constructor function versus in prototype duplicate. So in creating JavaScript objects, I can put a method declaration either in the constructor function or in the prototype. For example, say I want a doc class that has name property and bark method. I can put the declaration of the bark method into the constructor function like this, okay? Or I could put it method in the prototype object. I'm going fast because a lot of things already know, but I still want to take my time. Oh, sorry, I missed it. Oh, you're talking. You two guys think. All right. Sure, and you can do it on the prototype. So, should I prefer one of these approaches over the other? Are there any advantages, so on and so forth? So let's see. Now that we have context, for the example you give, you should use the prototype approach. In general, it depends. The main advantage of the first approach, initializing methods in the constructor, is that you can take advantage of closures by making use of local variables defined within the constructor in your methods. These variables are not directly accessible outside the constructor function, so are effectively private, meaning your API is cleaner than if these variables were instead defined as properties on the object. Some general rules of thumb: if your methods do not use local variables defined in your constructor, your example doesn't then use the prototype approach. So this .name.bar, he's saying if your methods do not use local variables defined in your constructor, so I mean, is this a local variable, this .name? He says it's not, but if you're creating lots of docs, use the prototype approach. This way, all instances in example objects created by the doc constructor will share one set of functions, whereas the constructor way, a new set of functions is created every time the doc constructor is called using more memory. So we read already about this, but this is I understood it better when I read this through. Okay. Oh, you worked as a front-end web intern? Yeah, that's kind of like me. I started in 2017 to learn programming. I learned Java, went to bootcamp, but then I got a job writing COBOL, so I've forgotten most of this and I'm going back. Yeah, front-end intern, it sounds interesting. I want to be a front-end intern. If you are creating a small number of docs and find that using local private variables in your constructor improves your code, this may be a better approach. Use your judgment and do some benchmark if performance or memory consumption are major concerns. It is possible to use a hybrid approach whereby only methods that need access to a local private constructor variables are defined in the constructor, while other methods are assigned to the prototype. For example, the code below uses a local variable in the constructor to keep track of the number of times the dog has barked, while keeping the actual number private, so the barking related methods are defined inside the constructor. Tail wagging does not require access to the number of barks, therefore that method can be defined on the prototype. I'm still a student as well. Nice. You're freelancing as well? Nice. Wow, what freelance work are you doing? So I'm getting out of this that it's better to use the prototype for most use cases. Alright, this is Scrimba. Those are really interesting. I have to put my headphones on. This, like, I don't know if you've used these, but these are like interactive tutorials. So let's play it and see what they have.
Hi there. Previously we learned that we can define an object with object literal syntax. Essentially, we have a
Right now I have a couple of projects, web pages, landing, and more than anything. Perfect. Aside from top, I'm a high school student. Oh, you're still in high school. Wow. Nice.
variable name, the name of the object, which is equal to one or more key value pairs. These are wrapped in curly braces. To extract information from the object, we can use either dot notation or bracket notation. With dot notation, we'll take the object name and attach.
How old are you guys? I'm
and
23, about to turn 24 in January. 22 here, nice.
And we are returning
We're
the value,
the same age.
also called
18,
value.
nice. Life is ahead of you.
Dot notation is cleaner and usually preferred, but at times you will need to use bracket notation. Take a look. Oops. We can't access the value of obnoxious property with dot notation since it is a string with.
This is exactly the same as in the Odin project example, like it's the exact same code.
The space inside of it. We can get this value with bracket notation though. With bracket notation, we are returning obnoxious property, which is a function that does stuff. On the other hand, you can't use variables in dot notation. Here we have a variable. We'll try to access it first with dot notation and then with bracket notation. When we look in the console, we see that my object.variable returned undefined. With dot notation, it's looking for a key called variable, which doesn't exist. When we use bracket notation, my object with variable in brackets is essentially the same as saying my object with property, this string that is the value of our variable. This time, the program looks for this value and it finds property and returns the value. Objects can be a way to organize your code by grouping related items. Here I have a game of tic-tac-toe. I have 2 players and each of them has a marker. I can use an object literal to group related items. I've created an object, player 1, with a player's name and marker, Tim and X. If you'd like, you can pause and create an object literal for player 2.
Wait. So the cool thing about this is like a live editor, so I can go in and do that. Player 2 equals, and I can do the name and what is it? Gen, and after that I can do the marker and it's an O. Alright, so I can after that resume it. And I guess when you stop it, or wait, so when you pause it, start typing, no, hit, commit, hit, so, no, I'm not exactly sure how you work with that, but I've used it 1 or 2 times, it just seemed fun. I even wonder how Scrimba works, it's pretty cool, yeah, indeed. I wonder how it works too. Why is it not playing now? There is some weird thing. Origin. I don't know what I did, but I cannot continue. Alright, I fucked around and found out Now I cannot continue. I don't know what to do. Wait, run. Commit 1 minute ago. Alright. Lady, where are you? She's not saying anything. Alright. Oh, run. I don't know what I did, guys. It's not working. Interactive Scrimba. I mean, it's the same. Thank you whoever subscribed. Okay. There you
Hi
go.
there.
It even
Previously
has a
we learned that
little
we can translate
checkpoint.
that to player 2. We have
Exploded.
Jen as our player, and their marker is O. The difference between example 1 and example 2 is just a few lines of code, and so it doesn't seem like it's making a big difference. But we actually gain some special powers when we use objects to organize our code. In this case, since we know we have multiple players, we can write a function to return properties for each player, instead of needing to remember all of the variables from the first example. With a 2-person game, it isn't so bad, but what if we had a game with 4, 8, 10, 100 players? The beauty of objects is we can write reusable functions like this to access data. I can call print name for player 1.
It's a
I'll
very
return
primitive
10. I can use
tic-tac-toe.
print name.
It's a
player
concept
2
of a
parameter.
tic-tac-toe.
And this time we get Jen. Nice. Another thing to consider is that we might not know which player's name we want to print. For example, we might have a function that prints a message about the winner at the end of the game. Presumably, we don't know this when we start the game. Here we have a function called GameOver. It takes winning player as a parameter. Winning player may derive from another function with a conditional for whichever player reaches the high score first. For example, I have a function called keepScore. Inside, I've got a conditional. If player 1 has a score greater than or equal to 10, we'll invoke the GameOver function with player 1 as the parameter. Other will invoke GameOver with player 2 as the parameter. For convenience, I can add score properties to each of my player objects in order to call keepScore and in turn GameOver. And we see that Tim is the winner. Yay! If we have a specific type of object we need to duplicate, like players in a game, a convenient way to create them is using an object constructor, which looks like this. This dot property will be the key, and the parameters that we pass in will be the corresponding values when we create a new object. And new is an
You can
important
scroll
keyword,
out the
actually.
display.
We can call the constructor
It's crazy.
function or instantiate
You
a
can
new
select the
object,
code,
player,
copy it.
by declaring a variable and using new player and passing in our parameters. We can console log the entire object or just particular properties of that object. Here we're logging the name that we just passed in to the player we created. Remember at the beginning of this scrim, we had my object, which had the key obnoxious property that was set equal to a function. We can do that here as well. With this dot say name, and define a function that will log name to the console.
But we already
Here
know
I've
it's
created one player
better
object
to
with the
define
syntax
it in
we
the
just went
prototype.
over. Here's a challenge for you. Pause the screencast and create another player object, which will include a name and a tic-tac-toe marker as parameters.
We've done this already. Go ahead.
All right, I'm going to change player to be player 1, and then I'm going to create another player named Stephanie, and her marker, of course, will be O. Now I can take my first object, player 1, and I can chain this say-name function. When I run this, we log Steve to the console. I can do the same with player 2, and I'll run. We've logged Steve and Stephanie. All right, let's look at objects from another angle. Every object in JavaScript has a prototype. Basically, a prototype is another object that the original object inherits from. The object has access to the prototype's methods and properties. When using constructors to make objects, it's best to define functions on the prototype of the object, like we've done here. This way, a single instance of each function will be shared between every student object that we create. If I create a student I can chain these functions to my new object, and we're going to log this name to the console. So instead of declaring the function inside of our constructor as we did before, we define it on the prototype so it isn't duplicated every time a new student is created. This would take up lots of memory and make each object larger than it needs to be. Why don't you get your hands on the keyboard and create a new student object the way I did here, and then call one of them that we've defined on the student prototype and chain it to your new student object. Hopefully that worked out well. So this time I can create another student. We'll call student 2. I'll declare a new student. I'll name him Mario, grade 8. And this time I'm going to chain the go to prom method to student 2. And when I run this, go to prom? All right.
Sure.
The recommended way of setting a prototype of an object is with Object.create. This will return a new object with the specified prototype in parentheses. We can use a constructor to give the object additional properties. Let's look at the following code. We have an object called student. The constructor is actually empty this time. Even still, we can define a function on the student prototype called sayName, which will log the student's name to the console. We have a different object, 8th grader, which does have key value pairs in the constructor. We want 8th grader to inherit the prototype of student. So we have 8th grader.prototype. We'll set this equal to Object.create
Lizzie, I
with
didn't
our
get
student
that, sorry.
prototype in parentheses.
What do you mean by what is
This
your
is how we want to
problem
set
solving
the prototype,
age?
and not this way. This will set the 8th grader prototype to the student prototype, not a copy, and this can cause problems later if you try to edit something. For example, what if we later create a 9th grader prototype and we also set this equal to the student prototype? Then
What's your problem solving method when you're stuck? Well, either I'll Google it, I'll ask ChatGPT, or I'll take a rest for however long I need, 10 minutes, 30 minutes, an hour, a day, doesn't matter, and I'll come with a fresh mindset and try to think it through once again.
we want to define a method on the 9th grader prototype that logs a mischievous message to the console. We can instantiate a new 9th grader, and we can chain this method.
Thank you for joining the stream.
Name. And when we run this, it's fine. It logs ha 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 to the console. But now if we create an 8th grader object and we chain the sayName method to our 8th grader object, we are expecting the sayName function that we defined on the student prototype, which will log this name, Mary. But when we run it, we get a nasty surprise since we set the 9th grader prototype to the student prototype. Here's a challenge for you. Can you pause the screencast and fix this code? Take a moment and do that now. We'll walk through it together when we get back. All right, well, we have the hint right here, so we'll just take out this mistaken code. We'll uncomment our
are you doing it right now? Because I did it this morning actually.
Object.create with our student
stream
prototype
as well, so
inside. And here, where we've made the same mistake again, we want to set it equal to Object.create.
It had some challenging parts in it
student
as well,
prototype
indeed.
in parentheses. Now when I run our code again, we log ha 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 for student 1, our 9th grader, Josh, and we log Mary's name for our 8th grader object. All right, we've talked about objects, object constructors, prototypes.
Scrimba is a really cool site, and almost everything on it is free as well. Great learning resource in my opinion. But yes, I'm going through it right now. Grid is kind of complicated for me right now. Yeah, I understand. I just went through it today on stream as well. What is it? Admin dashboard. Oh. Nope. Let me see where I have it. .com. GitHub.com. Sorry. what is it, admin dashboard, and in the actions we'll be able to see the deployment. There you go. I've made it more for like this screen size because the screenshot they provided is not a widescreen image, but it's a 3x4. What part are you having trouble with? I can maybe try to explain what I did there. Is there a course for Solidity on here? Courses. You have heard of 100 devs. They have a web dev bootcamp as well. He explains it very simply. No, I haven't. I'll check them out. 100 devs. Wasn't that the guys that make games? Or why is there no search function here? No, there is no Solidity. That's a bummer. Topics, AI, blockchain, nope. Can I remove those? How do I remove the filters? Nope. Alright, there is not what I was looking for. But anyways, if you have an issue with the dashboard, type it out and maybe I'll be able to help. We'll see. So this is the final video we have to. Oops, sorry for the rape. This is the final video we have today. This is JavaScript, this keyword explained simply.
What's up, people? It's DevSage here, and in this video I'm going to be teaching you about the this keyword in JavaScript. So what is this?
What is this?
This is a keyword that is used to reference the object that is executing the current function. That's it. This is a reference to the object that is executing the current running function.
Okay.
So what do I mean by that? So let's say we have a function test, and inside of this function, let's console log this.
The quality is a bit poor,
let's
sorry.
call test here. So our
will your previous experience with COBOL help you with your full stack career? Probably not. The only thing it helped me with is it kind of kept me in that developer mindset, because for more than 2 years I haven't done any of this, but being like a developer of some sort. Did you study computer science? No, I haven't even go to university, but it just kept me in the loop sort of, but it will not directly help me with what I'm doing with JavaScript and web development, so on. It's very far from that.
our function is test.
It is a lot simpler as well, and if you're based in a first world country, if they need COBOL developers, they'll probably teach you how to do the work, and it's very easy money. It's just nobody wants to do it, let's put it that way. But the language, like the syntax, the logic, everything is very, very simple, much simpler than what I'm learning right now, for example.
It's being called here. This is going to refer to the object that is calling test. In this case, test is being executed from the global scope. So that means the object that is calling it is technically the window object, since window is on the top level. So if we save this, we can see that the window object gets printed out. And that's pretty much the gist of this. It's a reference to what
jobs available. Yes, there are few jobs available. The thing is, there are like nobody wants to do that. Like most of the people haven't even heard of COBOL, but banking institutions, stuff like insurance and so on. America's healthcare is also like all the systems are built on COBOL, and they need maintenance at the very least. And everyone that knows Kobo is retiring or dying. They're like very old people, and they they need new employees to keep the code bases alive and to maintain them. So there is a lot of hunger for Kobo engineers, but there are not a lot of them. So when someone is hiring for a Kobo role, they will be open to teach you. If you don't know anything about it, they'll be open to teach you. Are you currently working? Yes, working 9 to 5. I did a stream before work, and that is a stream after work.
Whatever object is calling the current function.
So,
do you want to become a software engineer? If you don't know where to
sorry
start,
about that.
I'm Jacob. I'm a professional software engineer based here in New York City.
but if you want work that's not really that complex and it's like easy work, then you're really grinding. Yes, today is an exception. Today we've been going at it hard. Hopefully tomorrow as well. But yeah, I want to learn this and switch careers. It's just not interesting to me anymore. I cannot complain about the money, the benefits, anything, but it's just not interesting, and I cannot relocate because I work in a bank and I have to go to the office sometimes. Also in my home city that I want to move back to, there is not a Kobo job, so I cannot do that.
Let's take a look at another example.
Have you heard about Bolt? What is Bolt? I'm not sure if a Google search will... Yeah, this is what, when you say Bolt, this is what I think of the talk.
So let's get rid of this code and let's paste in a user object here. This user has a first name, a last name, and also a full
Bolt NEE. Is it new? Bolt.new? What do you want to build? Fuck that. Alright. I want to build a Fiverr-like marketplace where on one side there will be influencers, there will be social media influencers. Influencers is not like a word, and they will be offering their services and user generated content, and on the other side you will have businesses that will be able to hire the influencers and find them in one place. We will act as a marketplace and will secure the transactions between them until the service is provided and take a 10% cut. How's the day in a Kobo developer like? You get up, you go to the office, get something to eat, go in a 10-minute Scrum meeting, they give you your tasks, you do your tasks throughout the day. In my job nobody really follows me. As long as I get my work done, they're fine with that, so I can go to however many breaks I want. I can work from home, go to the office, just do whatever. If I do my work, they're all fine, whatever I do. My best friend can prepare group Discord, your YouTube channel. Right, I'm actually working on the Discord. The server is already done, but I'm making it like I'm making channels, roles, I want a Discord bot as well and so on, and I want to see how it works, so I'm doing it myself. But thank you so much. Right, let's see what this will spill out. Of course I have to sign up. Wait just a second. Don't have an account, create one here. Alright, continue with GitHub. If they hack my account, I'm God. Alright, act on your behalf, email address, read. Alright, it's fine. Bot just gives you everything, it also gives you a nice template to start with. Alright, let's see how that works. Fuck that. I'll help you create a modern production-ready marketplace for connecting influencers with businesses. Let's start with a beautiful language page on core features. If that actually fucking works, I'm quitting web dev. Creator Connect. I think it will do the front end, but the back end functionality I don't think it will do. Check preview. Where is the preview? Ah, wait. So you can watch the preview live. Nothing shows up for now. Maybe it's still doing it. But the preview is not. Ah, wait. For influencers. If there is nothing on the screen, just tell it to fix. There is nothing on the preview window. I think I'll have to let it just finish with that. I think it will take a while probably. But that's sick. Even like if it doesn't give you that good of a result, it does a lot of work in like seconds. Still writing. Yeah, I gave it like a little bit of a bigger project. Like that is essentially the project I want to do after I finish with the Odin project. This is like a personal project I want to do. And AI typically fails at anything medium to hard difficulty, so waiting for preview. I'd actually wait. So I would just want to see how it, yeah. Probably you could like oh, I couldn't copy it. Probably you could troubleshoot it, paste it back inside that error. But yeah, it gave a white error, I just saw it. Also let me fix the issues, okay. Wait, let me copy it fast. Alright. Paste it back inside and let's see what it does. For brands, is that TypeScript? I'll fix the syntax error in the for brands file. Okay, I'm just curious what it will spill out. But that's a very interesting tool. And it seems to be free, at least for now. Wow. Wow. No fucking way. I'm amazed. Nice. Obviously, well, can it do any of the backend stuff? I'm a creator. Start turning today. This is legit. I like this one. Thank you so much. Wow. Probably going to use that. Can you do the order and payment backend processing? I'll help you create a backend system for order and payment. Remind me why why am I learning web dev again? This is crazy. This is serious, we're doomed. This can't be real. You need to have API access to use Stripe for payments, I guess. Right. Maybe wait, payment processing, secure payment handling with Stripe. Replace the placeholder values in EMV. So we have to replace some stuff, but it will write it out. Wow. Yeah, it gives you a place to write your like secret key, so on and so forth. Get started. Get started doesn't work. Wow. That's legit. I don't know what to say. It's really amazing. Like, I don't know how much of the backend stuff it can do, but subscribe pro for 6 times more usage. I don't know. Who is the crazy person that coded this? Like, how do you even do this? It's amazing. Alright. Wow. Thank you for that. Now, because I don't have much more time, I want to watch through this video, and after that mark this lesson as complete. So I'll focus on this
property, which is a function that basically prints out the first
so we're
and
done
last
with
name together.
the JavaScript lesson for today.
So
at
if
least.
we were to call user.fullname,
That was
we'll
crazy.
see that the first thing we printed out is the actual user object itself, and then we have Patrick Scott. It was able to print the first name and the last name by calling this.first name and this.last name.
Alright, Patrick Scott.
So how did this work? So in this case, this inside of this full name property here, this is a reference to whatever object is calling this full name function.
Sure.
So how do we figure that out? One pro
User.
tip to determine what this actually refers to is to go to the function call and look immediately left of it, and whatever object is here,
Before the
that
dot.
is what this will refer to. So in this case, this refers to user. So that's why we can say this.first name, this.last name, because the this reference stands for the user object here. Okay, let's modify this example a little bit. Instead of using a regular JavaScript function here, let's try using an arrow function instead. So an arrow function is JavaScript's shorthand for regular functions, but they don't exactly work the same way as regular functions do when it comes to scoping. Arrow functions actually don't have their own this scope. An arrow function will inherit the this scope of the nearest surrounding regular function. So in this case, in our previous example, we had function. This function has its own this scope, but if we use an arrow function, the arrow function is going to try to inherit the nearest regular function's this scope. But in this case, there is no regular function surrounding it. So what it's going to end up doing is it's going to use the global object as its this reference. In this case, that's the window. So as you can see over here, we printed out window, and then instead of first name, last name, we have undefined, undefined, because there isn't a first name or a last name property on the window object. So that's just something really important to note when you're dealing with arrow functions and trying to use this. An arrow function will inherit the scope of the nearest.
What all languages do you plan to learn? Thanks for joining the stream. I plan to learn JavaScript, Node.js. I don't know if that's really a language, but TypeScript, just the JavaScript stack for full stack, Node.js and TypeScript. But yeah, we'll see where we go on from there. I just want to finish with the Odin project, and then I have more ideas, but we'll see. I'm just focused on learning one thing at a time, and I want to take it through. I'm not very good at JavaScript, currently trying to learn WoW. Yeah, me too, man.
Regular
Me
function. And if you don't have a regular
I'm not
function,
good
it's
at
just
all.
going to inherit the global scope. So what we can do to get around this, you can say function. This is just for an example, but if we have a regular function here, and let's say we have an arrow function inside of it, arrow function, and then we put this code in here,
So you can have it as a regular function.
and let's call arrow function. What's going to happen is line 6 is going to say, okay,
We can have the arrow function
am an
inside
arrow
the regular function.
I don't have my own this scope. I'm going to look up and I'm going to try to find the nearest containing regular function, and I'm going to inherit that function's this scope. So it's going to find the full name function here, and it's going to say, okay, I'm just going to use whatever you're using as your this reference, and I'm going to use that as my this reference as well.
Sure,
So
that
if we were to
makes
save
sense.
this, we can see that now we're printing out the user object again, and then we're able to actually get our first and last name again, because arrow functions inherit the scope of the nearest containing regular
That makes
function
sense.
that surrounds it. Okay, cool. So let's modify this example a little bit more. Let's actually get rid of this full name property and this call. Let's add an array to this user object. Let's call this array hobbies. Let's say programming and piano, and then let's add a method that's going to basically print out all of the hobbies. So let's call this list hobbies function, and then let's say this dot hobbies dot for each function hobby, pass the hobby in, and then let's print out console log hobby. Let's save that.
Programming.
Oh,
piano.
and let's call user.listHobbies. Okay, so we printed out
What were you guys talking about? The page broke again. Went for breakfast, dinner. Bro, they just showed me like this shit, and it fucking made a like a whole website with backend and stuff. Like, it was crazy. I just want to watch through the video though.
programming and
Sorry,
piano.
but you can maybe
So we're able
skip
to,
back a little bit. It was
inside of list
insane.
hobbies, we're able to grab the hobbies from the user object, loop over all those hobbies, and print it out. So let's make this a little more interesting. Let's say that I wanted to print out my first name along with my hobby. So let's try to use the first name property inside of this for each callback function here, not inside of list hobbies, but inside of this callback, and see what's going to happen. So let's say console log this dot first name. As you can see, we have undefined programming, undefined piano. So we're able to still print out our hobbies, but whenever we try to access the first name property, we're getting undefined. And that's because we actually entered in a new context here, because we have this function here. This for each takes in a callback function, and this function has its own scope, but it's not attached to the user. The user object is not calling this function. This function is technically being called from the global scope. It's not being called by any specific object necessarily. It's just being called by the window, by the global scope. So if we were to say console log this, we'll see that this actually refers to the window. So we have window programming, window piano. So this is obviously an issue because we're trying to access the user scope, but inside of this for loop function, we have access to the window. So how do we get around this? Well, for each specifically can actually take in a second parameter after the callback function. And this parameter can represent some object that you want to use as the this reference. So in this case, let's say we just passed in an object test. When I say test, test. This object is going to be used as the this reference inside of this for each callback function. So if I were to save this, we can see that here. Test, programming, test, piano. So what we can do is we can just pass in the this reference from the list hobbies function into
so just say this is it
function. So remember that this reference inside of list hobbies is pointing to the user. So we can just pass that in here, and it'll be used as the this reference. I was wondering why that is the callback with this. So let's try that. And as you can see, we have our user, and then programming, and then user, and then piano. So if I were to print out, if I were to add back this dot first name, we'll see Patrick programming.
That site is cheating straightforward. If you're learning this with them, yeah, indeed. I didn't think it would be that good.
Patrick piano.
We're doomed indeed.
Now it's important to note that not all methods are going to allow you to pass in your own this reference. This just happens to be what for each allows us to do. Let's see how the this keyword works with constructor functions.
I think we should become like builders and tradesmen if we don't want AI to replace us. Like learn a trade, but not programming because it's doomed.
So let's say we have a function user, and the user is going to take in a name, and we're going to say this dot name equals name, and let's console log this. So if I were to go down here and create a new user called DevSage, DevSage equals new user, DevSage, and I were to save this, we can see that we print out the DevSage user. That's what this references. Whenever you create a new object using the new keyword, the this is going to refer to that specific object that you just created. So if I were to create a new object, say coding phase equals new user coding phase, and I save it.
Yes, indeed, I want to build a business, but I want to code it, not use WordPress, because I already have a business, an e-commerce that's using WordPress, but I cannot deal with WordPress, man. I took my time to learn it and configure it, learn how everything works. It took me like 2-3 months, but it just has its bottlenecks and setbacks, so I want to code my next business myself, like the website, code it myself. But yeah,
we see that we print out the object that is specific to coding phase. That's what this represents. This is going to refer to the specific object that you created whenever you use the new keyword to create that object.
That should have been in the beginning of the video.
And
Not
that
at,
is a little bit
at
about
the end of it.
this keyword
This was
in
the
JavaScript.
simplest
If you
thing in the whole video. Alright, let me like it, and we can finally mark this complete. Wow, it was a blast. 3 hours 40 minutes of straight up learning. I think I took one break. So yeah, this was a whole lot to take in. And oh, next up we have a project that is very cool. So tomorrow morning we're going to start with this project. I'm very exciting. I thought it would be more learning, but we actually have a project to do. So I'm going to sign off for now because my time is up for the day, and tomorrow morning I'll have another stream. If you're not subscribed, please subscribe. Thank you so much. Thanks to happen. I think what everyone wants to do is to explain the extensive part and then give you the short explanation. A new project, that's good. Yes, indeed. Thank you so much everyone that stayed throughout the stream. I truly appreciate all of you, and I wish you a good rest of your day or good night's sleep. I'm going to have a good night's sleep and see you all tomorrow. Thank you guys, and until next time, love you all. Bye bye.